All right, let's get started. So, like Rosa said, I'm a staff engineer at FullScript, which is a platform for we help practitioners deliver holistic medicine to their patients. And our first commit was in 2011, and what we've seen is the business has like grown a lot since then. So when I joined, which was about 7 years ago, and we were a dozen engineers, and now engineering is more than 150. And as we grow and scale, what we're finding is the solutions that we had in the past are no longer scaling with the business. And like a good example of this is our background queuing system. So last year, we came to the conclusion that it was really time to say goodbye to Resque. Resque had served us very well for many years. And when our app started, Resque was kind of the clear choice. It was before Sidekick, which continues to be great today. It was before Active Job. But in the last couple of years, there's been some really nice improvements in kind of like rethinking what's possible in this space. And I think it started with Good Job and some improvements to databases themselves. Now using a database is a viable alternative to Redis. And after Good Job, SolidQueue was built as an alternative, and you could use like all the databases that Rails supports. So SQLite, MySQL, Postgres. And in 2024, SolidQueue was incorporated into Rails as the default queue adapter. So around that time, we were starting to like really think seriously about replacing Resque with something else. And it was because we had like a couple problems. The first was a dependency story. We were maintaining a bunch of forks that we never wrote and didn't understand. We also started to have this issue where our Resque workers would kind of just like take a nap at various times. They would just kind of stop working, and any jobs that were in the middle of running, they would just get killed, and they'd throw this error. And now we didn't lose any jobs because of this. We could always like manually retry them, but it didn't give us a lot of confidence that we had a reliable and resilient system in place here. And it was really kind of fairly mysterious as to like why this was exactly happening. The error we were getting was pretty like low-level C code, and we kind of had a choice. Do we invest more time and energy into Resque? Do we fix the bug? Do we get it going again? Maybe we have to fork Resque or whatever. Or do we invest our time and energy into an alternative? And so we started shopping around for alternatives. And I think like Sidekick is a great alternative. I think we would have been happy had we chosen Sidekick. Good Job is great, but it supports only Postgres, and we're on MySQL, so that's not an option for us. And SolidQueue at this time was made the new default in Rails. So we were like very curious about it. And there's some nice things about SolidQueue. So the main one is it's backed by a database. It supports MySQL, like I said. And while it's possible to have metrics and kind of like get information out of Redis, it's actually way more easy and straightforward just to make a read replica of your database, and devs can then go and write SQL queries and figure out what's going on in there. That's really nice. I like that a lot. The other major incentive is that it's part of Rails, which to me means it's going to be a robust solution that's well supported and maintained for the future. And we're heavily invested in Rails and the future of Rails, and it just made sense to use the defaults wherever possible. The other thing is that a bunch of us were really lucky enough to go to Rails World last year, and we watched Rosa's talk about SolidQueue, how it was built, how it works, and why Basecamp decided to build it. I really recommend watching one of Rosa's talks if you want to deep dive into how SolidQueue works under the hood. And we came away from that talk really wanting to give SolidQueue a try and see if it would be a good fit for us. So early this year, we started to work on it, and like here's the plan. So I'm going to go through this throughout the course of this presentation, and let's get started. So the first thing, you just need to make sure that all of your jobs are using Active Job. That's a requirement. Like I said, Resque was written before Active Job ever existed, so it has its own way of enqueuing jobs, and you have to kind of convert those all over to be Active Job. And we had luckily done this like years ago, so we were kind of ready to go in this scenario. The next thing you can do is you can set up mission control jobs, and this is the dashboard app, which allows you to retry or discard failed jobs. It supports both Resque and SolidQueue. And to set up SolidQueue is fairly simple. Like the README is really great, but there is a couple important decisions that you need to make. And the most important one is like, do you use your primary database or do you make a separate one? And the answer is really going to depend on the scale that you're operating in. For us, our primary database was not an option. SolidQueue is going to add like a ton of write-heavy load to your DB, and this could be a risk for us. We don't want to do that. So instead, we created a new MySQL queue database for production, but in development, review environments, staging, etc., we use the same database as our primary, just on a different schema. And for those environments, it's perfect. We can save on some cost, and we aren't worried about scale in those environments. All right, so pop quiz. What happens if this transaction gets rolled back? Well, the answer is it depends. So on Resque, there's no transactional integrity. The job is always going to get fired, and this can be a big source of bugs in your system. So a user never gets created, and then you try to send them an email. Great. But then this kind of like makes me ask a question, you know, like if we have a separate DB in production, but the same one in staging, would we have transactional integrity in staging, but not in production? Like, how's that going to work? And that would be kind of confusing. So it's really nice that in Rails 8, we have this config option for SolidQueue, and it allows us to toggle transaction integrity on and off for each job if you want. And this is false by default. So in this example, when in queue after transaction commit is true, transaction completes, job fires, transaction rolls back, job doesn't fire. So for us, while we're migrating, we just leave it off because we want to just mimic how everything's going in Resque. We don't want to change anything at this point, but we can think about like enabling it in the future. Okay, so to recap, we're using the same type of database. For us, that's MySQL as our primary, but we've configured SolidQueue to be on a separate database in production environments. We have no transactional integrity, and for now we want to keep things the same as Resque. And if you're curious about like figuring out transactional integrity, I recommend looking at the isolator gem. It's going to help you find all the places in your app where transactional integrity with jobs might be a problem. Now, the second most important thing to think about is like, how do you set up your workers? And to talk about that, I first need to talk about queues. So with Resque, we had some technical debt and was around how we named our queues. So this is a list of all the queues we had, and there's a lot of problems with this setup. So the big problem is we had a mix of priority-based queues and domain-specific based queues. And domain queues kind of like happen because maybe you first put your job in the critical queue because it's really important, but then there's a bunch of other stuff in the critical queue. So either your job is slowing those jobs down, or like something's slowing something down, and so you're like, I know what to do. I'm just going to make my own queue. Great, but this does not scale. Nothing else can go into this queue. Ops has to set up new infrastructure to support this new queue. And what happens when some notifications that need to go out immediately, and there's some that can go out in the next hour, and those are mixing together? You still have the potential problem where some less important jobs are slowing down the delivery of other jobs. And you also have a language problem. So what type of notification can I put in the notifications queue? I don't know. And priority-based queues are no better. The problem with this setup is no one knows what any of these mean. As a developer, you write a new job. Which queue do you put it in? I don't know. Maybe you know. For ops, when do you need to auto-scale the medium queue? Do you need to? Or is it okay if this job just fills up for most of the day and then clears up by the next day? I don't know. The problem is no one knows. So what do we actually want to know? We want to know, how long is my job going to sit in the queue for? There's a great talk from RubyConf 2022 called "What Does High Priority Mean? The Secret to Happy Queues." It's great. You should go watch it at some point. I watched this a couple of years ago, and like it kind of like stuck in my brain. And I thought, like, whenever we like touch our background queuing system, I'm going to do that. And in Daniel's talk, he really suggests naming your queues based on latency tolerances. So based on that idea, our job queue went from this to this. So this does a couple things. It makes it clear to developers and to ops what the queues mean. It becomes a contract. So each queue has an implicit SLO. What we're saying is here is jobs in the within 1 minute queue are guaranteed to run within 1 minute or less. That's the longest tolerable latency that's going to be acceptable for that queue. You put a job in the within 1 minute queue, it's going to get in and get out in under a minute. That's what we're promising. The beauty of this is we can directly tie our alerting to this expected SLO. If the queue latency is taking longer than it should, we can raise an alert. We can auto scale more resources. And that's because we now understand what each of these queues mean. And to get these names, we just made a spreadsheet. So we listed all the jobs, we assigned the team that owned that job, and we just asked, what's the longest amount of time that this job can sit in the queue before something bad happens? And then we aggregated that data, and we figured out these new queue names, and this is how we got them. So now we have our queue names, and what we wanted to do is we want to have dedicated workers for each queue, so meaning that they don't share resources. A worker is, these are basically just like Rails servers that we boot up. Each one is in charge of running bin jobs, which will run a SolidQueue supervisor, which will fork a separate process for each SolidQueue worker, and the worker, they just churn through jobs. And the idea behind this is that we can auto scale up and down depending on how busy we are. If the within 1 hour queue is very busy, the queue latency is getting a bit undesirable, we'll just like auto scale up more workers to address that load. But there is a bit of a caveat here. It takes us about a couple minutes for us to boot up a new Rails server. And if we notice that the queue latency is creeping up within 1 minute, and it's getting really bad and we want to auto scale it, by the time that new servers come online, we've already blown through our SLO. Now, to fix that problem, we just over provision the really fast queues. And that's been working for us, but it does mean that we have some servers just sitting idle for a bunch of the time. Now, this costs us some money, but our jobs get delivered even when there's an unexpected spike. The other thing that we wanted to do early on is just have some metrics. So we needed to know the queue latency, and what this means, in other words, is like, how long has the longest job in the queue been waiting for? And because SolidQueue is just a database, you can just query the database and get an answer, right? So we use Yabada gems, which basically will just like run this query at some interval. It'll collect those metrics and it'll push them up to Prometheus. And then from there, we can create some dashboards. And these are like an example of some dashboards that we built. Top 3 rows is queue latency. Red is bad, green is good. Bottom is the number of jobs in the queue at that time. And with these, we're able to monitor the health of our queues and just to make sure that we're meeting our SLOs or not. Okay, so that's the setup. That's all the configuration and philosophy behind what we're doing. And then how do we actually like migrate from Resque to SolidQueue? And remember that ideally we want like no downtime, no lost jobs, right? And the answer is like pretty simple. So first of all, we just made this constant in our application job. This just lists all the queues that we're going to support going forward. Then we override the queueAs method. Now, this comes from active job, and what we're doing is we're just looking for the queue name. If the queue name is within underscore something, we just make sure it's valid. And then if it matches that, then we set the queue adapter to SolidQueue. If it doesn't match, we just call super, and it just does what it normally did. And we enqueue the job in Resque. And that's it. Then your changes are really simple. All you need to do is change the queueAs method in your job. And then when this is deployed, what happens is any job that was previously enqueued in Resque will stay in Resque, but new jobs are enqueued, getting queued with SolidQueue. Like pretty simple. And it mostly is this simple. So for 95% of our jobs, this was the only change that we needed. And what we did is we started by moving a couple jobs where it's kind of okay if something bad were to happen. If the worst case scenario happens here and we lose a bunch of jobs, it's like it's okay for those ones. And then we started with those ones, and then we started to take on ones that are higher risk, more complicated as we went, as we ironed out the kinks in the system. And I'll go through a few problems that we encountered along the way and how we solved them. But here's a tip. Pretty much all the problems we encountered was because our infrastructure was under provisioned for the needs of our system. And you probably like have a good guess of like what the needs of your system are. Like we did some napkin math as to figuring out like how many jobs are we running and what size of database are we going to need. And we got it completely wrong. So if you have something like this, though, if you get it wrong, everything's okay. So what this does is just an rounding queue block in your application job. If SolidQueue can't enqueue your job, we just rescue that error. We re-enqueue the job back into rescue, and this way you don't lose anything. Nothing bad happens if you make a mistake. You can like roll back that change. You have some time to figure out what went wrong, and you can address it. So a couple of problems we ran into. So one was we had too many arguments. So SolidQueue needs to store everything about your job in a table, including the job's arguments. And for whatever reason, we had a couple jobs that had an argument list that was insanely long. So by default, MySQL is going to store 65,000 bytes in the text column here. And for one of our jobs, it just wasn't enough. So the solution was just to make that column larger. So we bumped it up to medium text. This gives us 16 million bytes in MySQL. And that just solved the problem for us. But then we started to like migrating some more jobs in batches. And we see in mission control that like some workers are just starting to die. They would kind of just quit unexpectedly. Like, what's going on here? This was surprising to us because we configured our workers to have like a graceful shutdown is what you should do. So instead of like sending a sig kill, which is that signal mine in the error here, instead you want to send a sig term or a sig int. And it just tells the worker like, hey, we're going to shut you down. Finish what you're doing. Don't take on any more work. And then you give it a bit of time. And then only then if the worker hasn't exited, then you send a sig kill. And we were doing that. So this error was surprising. And it kind of reminded us of this like problem we were having with rescue. But then we realized, we dug a bit deeper, and it just turns out that we were just running completely out of memory. We added a few new jobs, and those jobs were just more memory intensive than the previous ones and required more resources to do what they were doing. The solution for us, we just bumped up the memory. We doubled it from 2 gigs to 4 gigs, and this is kind of a brute force solution, right? If you're really concerned with like cost, you could separate out the jobs that require heavy use of memory into their own queues. You could separate out queues that have high CPU into their own queues, for example. You could do a within 1 minute high memory or within 1 minute high CPU if you really wanted to. But for us, it's not a big concern, and we just prefer to keep it simple. So bumping up the memory made the most sense for us. The next problem we encountered was we ran out of database connections. Why was that happening? And as it turns out, we did this to ourselves. What happened was we migrated a new job over to SolidQueue, and it was set to run on a cron. So at 1 p.m. Eastern, it enqueued tens of thousands of new jobs at the same time. And our autoscaler did exactly what we told it to do. It increased workers to meet demand. It made so many workers that we just ran out of database connections completely. Now, the solution here was just we increased the size of our database. Again, we'd under-provisioned and underestimated what we actually needed. And we use AWS for this. We just did like a blue-green deployment to beef your database. And to do this, you just kind of like basically just creates a replica of your instance. And then when they're in sync, you just swap the load balancer, and then you're on the new instance, essentially. And now we have like more than double the DB connections that we had, and that kind of leaves us with a lot of room for any spikes going forward. We also, though, put a limit onto the number of workers that we can auto-scale up to so that we don't do this to ourselves again. Okay, so you might see a problem with this setup, though. So like what happens, for example, if someone takes a job that takes a really long time to run. Imagine we have a job that takes 5 minutes to run from start to finish, and someone puts that in the within 1 minute queue. Like, that's not going to work, right? So the problem with this is if you have these slow jobs, they start consuming all the threads on your workers. And what that means is that worker can't do anything until these jobs finish running. You end up with a backlog of jobs just waiting for the queue to be executed, and it's essentially blocked. So to ensure this doesn't happen, we just wanted to set up a mechanism in place to enforce the idea that fast jobs need to run on the fast queues, slow jobs can run on the slower queues. And we set an objective of 1/10, so 10% of the allowable time. So within 1 minute, that's 6 seconds. Within 5 minutes, 30 seconds. 10 minutes, 1 minute, you get the idea. And to do this, we just set up a rule in a round perform action in our application job. And all this does is measure when the job starts and when it finishes. So if it's longer than 10% of the queue's name, we just send an alert up to Sentry. This way we know if a job is like too slow for a given queue, and we'll either just move the job to a slower queue, or we'll work with that team and we'll figure out like how can we make this job more performant so it can stay in this queue. The other challenge we came across is delayed jobs. So what these are scheduled jobs that you scheduled at some point in the future. Now I got to be clear, I don't like this pattern, but we actually had a lot of jobs like scheduled like so far into the future. Like I'm talking like I will be dead before they ever run. And this is not a great pattern. Like a lot can change from now until then. And a lot of the work was just like refactoring that code so that this doesn't happen. Maybe we set up a cron job every day and we check like what jobs we need to run today, and we do that. But some jobs we did need to migrate over. And to do that, we wrote this gnarly script that doesn't fit on a slide. I'll include like a QR code at the end of this talk so you can grab this code if you need it. But it would basically go into Redis, grab the scheduled jobs, and then convert them and enqueue them into SolidQueue, and then delete them from Redis. That's what it does. And it's like fairly complicated. Some of these jobs were enqueued in a version of Rails that was fairly old, and the arguments are like different between different versions of Rails. And it was, we had to support all those, and it was like kind of gnarly. But we did it. It happened. The other insight that we had is that MySQL is just not the same as Redis. So my thinking is that like Redis, you can kind of just like throw anything at it and it's like mostly fine. It doesn't really seem to care. But for a relational database, that's probably not the best. And what we noticed is that we had these kind of like big peaks and valleys of like CPU and database connections and load. And that's not ideal. And I kind of wanted to like flatten this curve. Like how can we make this like more round? What's actually going on here under the hood? And we looked into it, and most of that was just you have something and you enqueue thousands upon thousands of jobs, one after the next. And this is pretty expensive, right? And I wanted to decrease those peaks. So a really kind of like easy way to do this is you can just do like a find in batches. What you can do is in this case, you initialize 500 jobs into memory, and you pass this to active job perform all later. And so instead of 500 SQL insert statements, one after the next for this batch, and there's probably more batches to come, right? It's just one SQL insert statement per batch, which is really nice. And the other thing you can do, if you want to get a bit fancy, is you can like set a random wait time for each job, and this will spread out when the jobs are actually run from 0 to 30 minutes, and that'll kind of like spread them out a bit more if you want to do that. Now, assuming you've done all this and converted everything over, you're pretty much ready to swap the queue adapter over to SolidQueue. So just don't forget, there's gems that might be using it, there's mailers, there's active storage. Don't forget about those. But at this point, like once you deploy this and everything's working, you're pretty much ready to delete Resque from your code base. All right, so that's what we did. How did it go? So we had about 2 devs working on this for a couple months, including myself. And we migrated all the jobs over in that time. And most of the work was really just setting up SolidQueue and adjusting our infrastructure when we got it wrong. But once we were confident, we could kind of just migrate the jobs in big batches over a couple of weeks. It was like pretty fast once we kind of figured it all out. We had one dev from ops to help us set up the infrastructure and fine tune it as we went. And we also had a DBA that made sure that our DB was like running properly and we had good metrics for it. Everything was running smooth. So this is probably the best screenshot I have of the difference between running jobs in Resque versus SolidQueue. One of our team leads sent me this message with this graph. He thanked me for fixing the problem, and all I did was switch the job from running from Resque to over to SolidQueue. And what these are just like job failures for a high volume job that we run every day. On the left is the job running with Resque, and on the right is when we switched over to SolidQueue. All those failures just stopped cold. We had really achieved the reliability that we were after. And all in all, I'm like really happy with it. We're processing about like 3 million jobs a day. Performance of SolidQueue is amazing compared to Resque. In fact, it's too good in a lot of instances. For our within 24-hour queue, the queue latency is like 30 seconds or something ridiculous. We need to kind of like slow something down in there, like reduce the resources or something, and I'm not sure yet. But it's really easy to horizontally scale more workers based on demand. That's really nice. The observability is great. Being able to write SQL queries and just sort of see what's going on, awesome. And I think renaming our queues was one of the biggest benefits, just gaining a lot of understanding as to what the queues are and what they mean. And again, like I said, reliable. Really like the reliability of it. It's been running smooth, and I'm really happy with it. Thank you very much.